Hello my students, today we are learning about still simple titration. This is lesson 26, simple titration. Here we have this question: 6.8 gram of citric acid which is H3Y, we don't know why, containing 1000 milliliter of solution, and we have the molarity of the acid 0.112 molar of sodium. This is the molarity of the base, 0.112 molar of sodium hydroxide solution. Then the procedure is saying like this: fill the burette with sodium hydroxide solution. Then you fill the pipette by using a pipette. You pipette 25 centimeter cubic of the acid. Then you place in a clean conical flask. Then you add 2 drops of phenolphthalein indicator. Then you carry out the titration. So the initial volume here is 0, 0, 0. The final reading is 23.83, 23.83, 23.83. Then the volume of the acid used, the volume of the base used is 23.83, 23.83. So the first question is asking the calculate the average volume of the base, which is sodium hydroxide. To get Roman 1, the answer of Roman 1 is you will do this: calculate average volume, which is 23.83 plus 23.83 plus 23.83, then you divide all of them 3. So when you add all of them, this is what you get. You'll get 23.83 plus 23.83 plus 23.83. This is what you get. You get 71.49. Divide by 3, then you get 23.83 centimeter cubic. So this is the volume of the sodium hydroxide used. This is the volume of sodium hydroxide used. So that's how you'll get it. Roman 2. We have Roman 2, the number of moles of the sodium hydroxide used. So to get the number of moles of sodium hydroxide used, we have the average volume, which is the volume of sodium hydroxide used. We also have the molarity, which is 0.112. Say 0.112 molar, which is the molarity of sodium hydroxide, is equal to 1000. So equal to 1000 centimeter cubic or milliliter. What about this volume, which is 23.83 centimeter cubic? So this volume that we have here is the volume of sodium hydroxide. Then we do cross multiplication. Then we get 0.112 multiplied by 0.112 multiplied by this, which is 23.83 centimeter cubic all over 1000 centimeter cubic. So centimeter cubic and centimeter cubic, they cancel each other. This is what you get. You multiply 0.0 0.112 multiplied by 23.83 divided by 1000. Then you'll get here, you'll get 0.00267. This is the number of moles of the base, which is sodium hydroxide solution. So this is the number of moles of sodium hydroxide solution. Okay, that's how you'll get it. The next question, let me go to the next page. The next question is this. My blackboard is different. The concentration of a citric acid in gram per liter. In gram per liter. So the concentration of citric acid, the citric acid, we have the mass, which is 6.8 gram. We have the total volume, which is 1000 ml. This is what you do. This is Roman 3. Roman 3, for you to solve Roman 3, 6.8 gram is equal to 1000 ml. Why am I saying this is the volume 6.8? The mass is 6.8 gram of the acid, citric acid. Then citrus acid is equal to 1000 ml. Then what about 1000? This new 1000 is the concentration. What about 1000 ml? I don't know. Cross multiplication. Then 6.8 gram multiplied by 1000 ml, which is this one, divided by this 1000, which is multiplied by x. So ml and ml they cancel, 1000 and 1000 they cancel. So the answer is 6.8 gram per liter. This is the molar. This is the concentration in gram per liter of the citrus acid that we don't know. H3Y. Roman 3. Roman 3, not Roman 3, Roman 4. I mean Roman 4. Roman 4. Roman 4 we have. Roman 4 we have the number of moles of the citrus acid. So to get the number of moles of the citrus acid, we react it these two. H3Y aqueous plus sodium hydroxide aqueous, we will get sodium 3Y aqueous plus water plus water. Why am I writing this way? Because the acid is tribasic. It has 3 hydrogen, so it contributes a radical. Y is a radical. That radical of Y has a valence of 3. Yes. If the acid is monobasic, the radical that it contributes, or the salt that it contributes to the acid, it is always contributes 1 valence. If the acid is dibasic, like sulfuric acid, carbonic acid, so such acids they contribute valency, a radical of valency 2. So if the acid like phosphoric acid, tribasic, it has 3 hydrogen, it contributes a salt of 3, valence 3. So that's why sodium is taken 3 here. So let's balance here without wasting any time. Sodium here 3. Sodium, let us make it here 3. 3 sodium. Balance sodium. Y here 1, Y here 1. Hydrogen 3 plus 1, 4 hydrogen. So we put it also 2 here to balance hydrogen 4. So oxygen 2, oxygen here 3. Oxygen is not balanced. Oxygen 3 here. 3 oxygen we have here. And here we have only 2 oxygen. So we make oxygen 3 here. We make oxygen 3 here. Sorry, I have not balanced hydrogen. Hydrogen 3 here. 3, which is this 3 plus this 3, 6. So 3 times 2, 6 hydrogen. Oxygen now 3. Oxygen 3. Balance now. So the mole ratio is 1 to 3. The mole ratio is 1 to 3. So therefore, if the number of moles of the acid, if you have, then you can the number of moles of the base, if you have, you can get the number of moles of the acid. So the number of moles, the mole ratio is 1 to 3. 3, which is the mole ratio of the base, is equal to the number of moles of the base, which was 0.00267. 0.00267 moles. What about 1 mole ratio from the acid? So x we don't know. We cross multiply. 1 times 0.00267 all over 3. We divide by 3 these values. So 0.00267 divided by 3. We will get 0.000089. 0.00089 moles. So this is the number of moles. This is the number of moles of the acid. This is the number of moles of the tribasic acid. Okay. The next question is the concentration of the citric acid. To get the concentration of the citric acid, Roman 5, it's very simple. This is what you do. 0.00089, which is the number of moles of the citric acid, is equal to the volume of the citric acid used, which is 25 centimeter cubic. Where am I getting this? Let me go back to my question. Using a pipette, place 25 centimeter of citric acid. This acid, this is the volume of the citric acid used. So that volume is equal to the number of moles used. Then what about 1000? 1000 centimeter cubic. How much will it be equal to? We don't know. You cross multiply. then you'll get 0.00089 multiplied by 1000 all over 25. All over 25. Then this is what you get. This one multiplied by 0.0098 times 1000. Sorry, 0.00089 times 1000 divided by 25. You'll get the molarity of the acid will be 0.00. Sorry for that error. 0.0356356 molar. So that's the molarity of the acid. Yes, that's the molarity of the citric acid. Okay, the next question, which is question Roman 6, is asking the relative formula mass of the citric acid, and Roman 7 is asking the value of Y. Now, to calculate Roman 6, so to calculate now you use this formula. Molarity is equal to concentration in gram per liter over RFM. Now the concentration of the acid, we have it here, 0.035. The molarity is 0.035, and the concentration, we have it here 6.8 gram. 6.8 gram. That's the concentration, and this is the molarity. So therefore, the molarity is 0.356. So next page, instead of molarity, we write 0.0356 is equal to concentration, which is 6.8 over RFM. We don't know. So here we have 1, then cross multiplication. RFM multiplied by 0.0356 is equal to 1 times 6.8. Then both sides we divide by 0.0356 divided by 0.0356. So this one and this one they cancel. Therefore, RFM is equal to this one 6.8 times 1 divided by 0.0356. Then we get it 191. Then to get now Roman 7, which is the value of X, we have H3 Y is equal to 191. To get the value of Y, hydrogen is 1. 1 times 3, we have 3 hydrogen, plus Y is equal to 191. Therefore, 3 plus Y is equal to 191. Then, now you transfer 3 to the side. Therefore, Y is equal to 191 minus 3. Y therefore is equal to 191 minus 3. You'll get 188. 188. So that is how you get the value of Y. Guys, I want you to be very careful with such kind of question. And our next lesson, which is lesson 26, we will be dealing with the back titration, symbol titration. We have done almost 2 questions plus another 3 questions plus 5 questions. We have almost done 5 questions. I think 5 questions is enough symbol titration. Our next lesson, inshallah, we are going to deal with a pack titration. And also pack titration, we'll see 5 questions. Then we go to double titration. We also see 5 questions. Redox titration, we also see 5 questions. Molar gas volume and atomicity. Then after that, Gay-Lussac's law, and that's the end of mole. Therefore, we will start a new chapter, which is organic chemistry 1. Then we'll go ahead like that. Okay, if you have any question, please, you can ask in the comment section. You can write any question, that if you have any question with these questions that I'm posting in my YouTube. Thank you.